Yo guys, we're back with Math Paper 4H from June 2010. And this is part 3. Okay, so question 16a, it says that a bag contains 3 white discs and 1 black disc. And John takes at random 2 discs from the bag without replacement, meaning he doesn't put the discs back in the bag. So you have to complete the probability tree diagram. Okay, so 16a is asking you to complete the probability tree diagram. So first of all, you need to write a probability for the probability of him taking a black disc out of the bag. So now since there are 4 discs and there's 1 black disc, that means that the probability of him picking a black disc as the first disc is 1 out of 4. Now, when he picks the second disc, so let's say he picks a white disc first try. So now when he's going to pick the second disc, he has again 2 possibilities, either picking a white or picking a black disc, right? But now, in this case, since he's not replaced the first disc, there's 1 less disc. So there's out of 3, right? Out of 3. And since he's picked out a white disc, right, because he's picked out a white disc as his first disc, that means that there's a 2 out of 3 probability of him picking a white disc and a 1 out of 3 probability of him picking a black disc. And the same thing with the black disc. So let's say he picks a black disc out. So now he has a white disc and he has a probability of picking out a black disc. Again, he hasn't replaced it, so that means it's out of 3. Out of 3. But now there's like a 3 out of 3 chance of him picking a white disc and a 0 out of 3 chance of him picking a black disc out, because all the blacks are out of the bag and now there's only whites in the bag. So you can pretty much erase this thing, because this is not a possibility anymore, and you can say that the possibility is white and the probability is 3 out of 3, or you can just say it's 1, right? And that is your probability tree diagram. Okay, so you have to find the probability that, in 16b, you have to find the probability that both discs are white. So if he picks the first disc out and it's white, he has a 3 out of 4 probability of picking the first disc that's white. But now he hasn't replaced the first disc, so there's 1 less disc, so that means it's out of 3. And then the probability of him picking another white disc is 2 out of 3, because 1 white disc has been gone in the first pick. Right? Remember the probability tree diagram earlier. So if he picks his first white disc, right, it's a 3 out of 4 chance, so white. But then if he picks another white disc, it's actually a 2 out of 3 chance, because there's 1 less white disc. So now what you have to do is you have to multiply these probabilities together. And that'll give you the probability that both discs are white. And so the answer is 6 over 12, which is actually just half. Okay, so question 16c, it says that all discs are now replaced in the bag, and this guy per leap, he takes 3 discs without replacement. So you have to find the probability that the disc left inside the bag is white. Now, for the disc left inside the bag to be white, there are 3 events that could occur where you have a white disc left. There's one event, which could be you pick out a black disc, then you pick up 2 white discs, and in that case you'll have a white disc left in the bag. Another event that could occur is you pick up 2 white discs in the beginning, then a black disc. And the last event that could occur is you pick up a white, then a black, then a white disc. And in the end you have a white disc left in the bag. So all you have to do is calculate the probabilities of each of these events occurring and add them together to get a total probability of the disc being left inside the bag being white. Okay, so for the first situation, if he picks out a black disc out of the bag, it's a 1 out of 4 chance, right? And then you have 3 white discs in the bag, and you have 3 discs in the bag in total. So the probability of him next picking, if he picks the first disc, if he picks it out of the bag, he has a 1 out of 4 chance of it being black. And then you multiply that by the next probability of him picking a white disc the second disc he picks. And if you think about it, he has a 3 out of 3 chance, because there are 3 discs left in the bag and there are 3 white discs. So that's a 3 out of 3 chance. Now, for the third disc to be white, it's actually a 2 out of 2 chance, because 1 disc is gone out of the bag and there are now 2 white discs left in the bag. So that means that this will be 1 out of 4, like the total probability will be 1 out of 4, because, yeah. Okay, then for the second event, right, so that was for the first event. For the second event, the probability of him picking a white disc at first would be 3 out of 4. Then for the second disc to be white, it would be a 2 out of 3 chance. And for the third disc to be white, it would be a 1 out of 2 chance. And so that would give you 6 over 24, or a 1 out of 4 chance. Okay, so that's the second. So now the third event, for him picking a white disc in the beginning, it's a 3 out of 4 chance. Then for him picking a black disc next, is a 1 out of 3 chance. And for him picking a white disc next, it's a 2 out of 2 chance. And that just simplifies to 3 times 1, 3, 6 over 24, which is again 1 over 4. So all we have to do is add all of these probabilities together, right? And we will get the total probability that the disc left in the bag is white. So 1 out of 4 plus 6 out of 24 is just 1 out of 4. 6 out of 24 again is 1 out of 4. So 1 out of 4 plus 1 out of 4 plus 1 out of 4 is 3 over 4. And that is your answer. Okay, question 17 is really easy. You just have to find the area of the sector. Now, in your formula booklet given at the start, they'll give you the area of a sector. And it's just basically the angle, which in this case is 84, divided by 360, times the area of any circle, which is pi r squared. And r is the radius. So in this case, the radius is 45. Look, 45. So 45 squared. And all you got to do is put this on your calculator, and you're going to get an answer of 1484.40 blah blah blah. But you have to give it to 3 significant figures, so it's just 1480 centimeter squared. Now, question 18 is also again very simple. I think it'll probably be on your formula booklet at the start, and this question has given you a triangle and is asking you to find the length of AC, which is the side opposite to this, right? And you have this angle over here and the side opposite to that, which is 3.4 centimeters. So you can apply this thing called the sine rule. Now the sine rule simply states that the ratio between the sine of the angle and the side opposite to it is equal for all angles and corresponding opposite sides. So that sounded a bit confusing. So let me just make it simple. Okay, so in this case you have 30 degrees and the side opposite is 3.4 centimeters. So sine of 30 over 3.4, this ratio is actually equal to that angle, and this we'll call this side x, sine of 110 divided by x. Alright? So basically the ratio of the sine of the angle and over its opposite side is equal for all angles and opposite sides in the triangle. Okay? And this applies for any triangle. So let's just solve for x. So to solve for x, all we have to do is multiply both sides by x, right? And it's actually a bit more complicated. So multiply both sides by x. So we get sine 30 times x over 3.4 is equal to sine 110. Then we multiply both sides by 3.4 and divide both sides by sine 30. So we're going to get x is equal to sine 110 times 3.4 divided by sine 30. Sorry, not sim, sine 30. And that'll give you an answer of x being 6.3899 blah blah blah, but you need to give it to 3 significant figures, so it's 6.39 centimeters. Okay, so question 19, they've told you that they've given you a cone and they're telling you the total surface area, TSA, I'll call it, is equal to 33 over 4 pi. And they've given you like values of the slant height and they've told you radius r, and they're asking you to calculate r. So what is r? So the normal equation for the total surface area of any cone is actually, the curved surface area, which is pi r L, plus the surface area of the bottom circle, which is as you normally know, it's 2 pi r. Pi r squared, my bad. Yeah, pi r squared. So yeah, so that's the total surface area of any cone. Alright, so in this case, L is 4 centimeters, as you can see. So 4 times pi times r plus pi r squared is equal to 33 over 4 pi. Correct? Since the total surface area is 33 over 4 pi, this actually makes sense. Okay, so now all we have to do is solve for r. So in this case, we can divide both sides by pi. So we divide both sides by pi, right? So this pi and this pi cancel, pi cancel, and pi cancel. Because you're dividing this term by pi and this term by pi, so pi's cancel. So you're going to get, 1 second, 4r plus r squared is equal to 33 over 4. Alright? I'll erase that because it's confusing. Yeah. So if I take this to the other side, I'm going to get r squared plus 4r minus 33 over 4 is equal to 0. Now if I multiply the whole equation both sides by 4, you're going to get 4r squared plus 16r minus 33 is equal to 0. Alright? Now you have a quadratic equation. Now what do we do with quadratic equations? To solve them, we just simply factorize it. So to factorize it, we have to think of two numbers that multiply to give you 4 times negative 33, which is negative 132, and add to give you positive 16. And if you just think hard, those two numbers are actually plus 22 and negative 6, right? So what you have to do is, like we did earlier, you have to split them into 22r minus 6r minus 33, and then you have to factorize them separately. So what we're going to do is 2r, and you get 2r plus 11 minus 2r plus 11. And then you got to factorize the whole thing, and 2r11 plus 11 is common, so 2r plus 11, and you remain with 2r minus 3. So now that is all equal to 0. So if I just do this a bit quickly, like you probably remember from before in the earlier tutorial which I did on this paper, so I can just simply say 2r plus 11 is equal to 0 and 2r minus 3 is equal to 0. And obviously radius cannot be negative, so that means that this is not possible, because if I solve this equation for r, I'm going to get a negative answer. But this equation is possible, so if I add 3 on both sides, I'm going to get 2r equals to 3, and if I divide by 2 on both sides, I'm going to get r is equal to 3 over 2. And so the radius is equal to 1.5 centimeters. So question 20 is about functions, and they've told you that f of x is equal to x minus 1 the whole squared. So first question, they're asking you to find f of 8. So to find that, all you have to do is substitute 8 in terms of x. So all you have to do is 8 minus 1 squared, and you're going to get 7 squared, which is 49. Okay, and for 20b, what they've asked you is, so question 20a is, the answer is 49. And for 20b, they're saying that the domain of f is all values where x is greater than or equal to 7. So x can only be 7, 8, 9, 10, and it can go on forever and ever. So you have to find the range of f. So range is all the possible answers that can happen from the domain. So since the domain is 7, the range is basically the answer. So for example, if the number you put in was 7, right? So it would be 7 minus 1 the whole squared, which would be 36. 36 is your answer, and the range is how many values the answer can go up till. So since it's greater than or equal to 7, it can either be 7 minus 1 squared, it can be 8 minus 1 squared, which would be 49, and so on. So if you actually keep repeating, you'd actually understand that the range is only, the range would be f of x should be greater than or equal to 36, because the lowest answer you can get is 36, and it can go on till infinity. So that means it can go on forever and ever. So that means that the range will be f of x greater than or equal to 36. Okay, so next question, they tell you g of x is equal to x over x minus 1, and they ask you to solve g of x is equal to 1.2. So all you have to do is x over x minus 1 is equal to 1.2 and solve it. So multiply both sides by x minus 1, you're going to get x is equal to 1.2 times x minus 1. So x is equal to, expand this out, 1.2x minus 1.2. Then what you're going to do is you're going to subtract 1.2x on both sides, so minus 1.2x minus 1.2x, right? And you're going to get negative 0.2x is equal to negative 1.2. Divide both sides by negative 0.2. You're going to get x is equal to negative 1.2 divided by negative 0.2, which is 6. Alright, so for question D1, they're asking you to express the inverse function g inverse of x. So you have g of x, and you just have to find g inverse of x. Alright? So when you want to find inverse, what you have to do is first write this out in terms of y, because g of x is nothing but y. So y is equal to x over x minus 1. Now when you want to find the inverse, what happens in inverse is that the x and the y switch. Okay? So x becomes y and y becomes x. So if you do that, you're going to get x is equal to y over y minus 1. Now all you have to do is solve for y, and you'll find g inverse of x. Okay, so we multiply both sides by y minus 1, and I'm going to rush through this a bit, because I'm expecting you know this. So you're going to get, if I multiply both sides by y minus 1, you're going to get xy minus x is equal to y. Now I'm going to continue up here. So if you add x on both sides and subtract y on both sides, you're going to get xy minus y is equal to x, right? Now if I factorize y out of this side, I'm going to get y, x minus 1 is equal to x. Divide both sides by x minus 1, and I'm going to get y is equal to x over x minus 1. So g inverse of x is equal to x over x minus 1. Alright, so they're saying, hence write down g of x in terms of x. Now from the previous question, we can understand that g inverse of x is actually equal to g of x, correct? Because we found g inverse of x and we found it was the same as g of x. So that means that this can actually be written as g inverse of g of x. Now, when you put an inverse function and you multiply it by the original function, what you're actually going to get in the end is always, you're just going to get this x over here. Okay? And you can try it out yourself. You can try it out, like for example, you can try it out with your own functions. But in general, when you have an inverse function multiplied by the actual function, you're just going to get the x you originally put in. So yeah, so your answer is just x. Okay, so question 21 is about vectors, and they've told you that OA is A and OC is C. Now for 21A, they're asking you to find the vector CA in terms of A and C. Now, what a vector is basically it's a quantity that has both magnitude and direction. So it has amount as well as direction involved. Okay? So to find CA is basically you have to get from C, you have to get to A from C. So you have to go in this direction and this direction. And if you want to put that in terms of A and C, if you look at it, it's going to be negative C because you're going in the opposite direction of C. So it's negative C plus A. And that's it. Okay, so for 21B, they say that the point B is such that AB, the vector, is equal to half C. Okay, now you have to give a mathematical name for the quadrilateral OABC. Now we all know that B can be anywhere now. Think about that. but it's equal to half c, meaning to get to b from a, you have to have this direction, because c has this direction over here. You see, c is the horizontal direction. So that means that, and c is a vector, so the direction does matter. And it's half of c, meaning the magnitude will be half of this, so it'll be about this much. So just draw that, So just draw that from A. So that's about half C. And this should be your B point over here. Now if you look at the quadrilateral formed, it's a trapezium because these two sides are parallel and then there are two other sides. So it means that the quadrilateral formed is a trapezium. So for question 21C, they're saying that the point P is such that OP is equal to A plus KC, where K is greater than or equal to 0. You have to state the two conditions relating to A plus KC that must be true for OAPC to be a rhombus. So first of all, one of the conditions for a rhombus, the rhombus shape is like this, where this side and this side are equal, and this side and this side are equal. Right? So all sides are equal. Actually, sorry, all sides are equal in a rhombus, and there's a slant. It's like that. Okay? So first of all, point P needs to be somewhere here. So first of all, we know that point P is from O, and it has some kind of C vector. So it should be in that direction. So in order for this to equal this, these two values need to be the same. So this needs to be a C as well. So that means that the point P should have a vector of A plus C. Because it needs to go like this, and it needs to have the same horizontal like amount as this line over here. So that means that it needs to be A plus C. So that means that K needs to be equal to 1. And that is the first condition. Alright? Now the second condition should be that in a rhombus, since all sides need to be equal, so all of these need to be equal, right? So that means that the magnitude of A should equal to the magnitude, I'll just call it MAG, of C, because their amounts need to all be the same to form a rhombus. Or like their lengths need to be the same, their lengths need to be the same, so their magnitudes should be the same. 22A is asking you to work out 5.2 into 10 to the power of 2 plus 2.3 into 10 to the power of 4. Now all you have to do is put this on your calculator, and you'll get an answer of 23,520. Now they're telling you to give your answer in standard form. So in order to put in standard form, all you have to have is, you have to make sure there's one decimal place, and it should be a single digit between 0 and 10. So it becomes 2.3, and you've moved in 1, 2, 3, 4 places, so it's into 10 to the power of 4. And sorry, it's not 2.3 only, it's 2.352 into 10 to the power of 4. Okay, 21b is slightly tricky. They've given you A plus, into 10 to the power of 2 plus B into 10 to the power of 4 equals C into 10 to the power of 4. Now you have to express in C in terms of A and B. So what I suggest doing is, when you have two numbers with the same exponent, basically the same into 10 to the power of, like the same number here, right? This is, if you have the same number there, it's just the addition of these two which will give you C. Okay? But in this case, it's 10 to the power of 2, and over here it's 10 to the power of 4. So our objective is actually to get this into 10 to the power of 4. Now how do we do that? Basically what we can do is we can say that A over 100 into 10 to the power of 4 is equal to A into 10 to the power of 2. Because if you think about it, let's say A was 1, yeah? So if you had 1 into 10 to the power of 4, and let's say you could write this as 0.001 into 10 to, 0.01, sorry, my bad, 0.01 into 10 to the power of 4, and it would still equal the same thing in the end. So A into 10 to the power of 2 can be written as A over 100 into 10 to the power of 4. Alright? So, using that, so we can say A over 100 into 10 to the power of 4 plus B into 10 to the power of 4 is equal to c into 10 to the power of 4. And that means that this plus this will give me c, because 10 to the power of 4 is remaining constant, right, throughout the equation. So that means that a plus b equals a over 100, which means a over 100 plus b is equal to c. So 0.01a plus b equals c. Alright, thanks a lot for watching Math Paper 4H from June 2010. Please comment if you have any questions, rate this video and subscribe to my channel please. Thanks a lot and stay tuned for the next tutorial.